My name is Kyle Sanchez, and this is the Anti-Package Theft Prototype Project. To start off, what is it? So my design is aimed at scaring the thief by making the package look like a bomb. So some of the features it has is GPS tracking, live GPS tracking to your phone via the Blink app, adjustable geofence and starting location. So it's enclosed in a small phone box, which is enticing to package thieves, a bright red 7-segment display, and a loud buzzer. So here's the code flowchart. An important note of this is that the rectangular boxes is the code running on the ESP8266, while the diamond-shaped boxes is code running on the Arduino Uno. So to start off, there at the top left, the 8266 checks if there's a valid GPS connection. If there is not, it just continues to check. If there is, it gets the current longitude and latitude data and sends it to the Blink app, which is what displays it live. It then calculates the distance from the initial position, and then checks the distance from the initial position to see if it's greater than the geofence radius. If it's not, it continues to get the current longitude and latitude data. If it is, then it sets the current status to stolen. All while this is happening, the Arduino Uno is checking the status to see if it is stolen. If the status is not stolen, the Arduino Uno continues to check. If it is stolen, the count function begins. In the count function, it displays the current number on the 7-segment display. It then checks, is the current number 0? If it is not, it then takes the current number and subtracts it by 1, and then beeps the buzzer. It then displays the current number again, and when it goes back to check to see if the current number is 0, if it is, then the system is complete and it continues to beep the buzzer. This is the GPS code that runs on the 8266, and I'll highlight some of the most important parts. This code allows the ESP8266 to connect to the internet. This code right here sets the initial position. This function right here checks to make sure that the GPS is operating correctly. This geofence function right here does a distance calculation on how far the box is from the initial position and returns a stolen if it is outside the radius and returns false if it is not. This loop right here checks to see if it is stolen. If it is stolen, then set the Uno pin to high. If it is not, set the Uno pin to low. When the device is connected to the computer, you can also see a live feed of the longitude and latitude data. This is the code that runs on the Arduino Uno and is in charge of the 7-segment display and the buzzer. So I'll show you the count function, which was also on the code diagram. This for loop counts down from the start number to the end number, plays the buzzer for a certain duration at a certain frequency. This if statement makes sure that the counter does not pass the end number. This for loop, which was provided by the example code, is in charge of the timing of the number changes and buzzer. And this has run equals true function is making sure that the code only runs once, which is checked up here in the void loop. Here is a wiring diagram of the hardware. In the middle, you can see the ESP8266 connected to the GPS module there in the red on the right. On the left, you can see the Arduino Uno connected to the 7-segment display, as well as the buzzer. It is important to note that the ESP8266 is powered via micro USB cable from a portable charger. The Arduino Uno is powered from the 8266. And here's a picture of the real-life wiring. So here is a closer view at the wiring of the project outside of the box. Here is the 8266 connected to this GPS module here. The red and black wires are power. The blue and green wires are the TX and RX pins. Going to pins D1 and 2. This is the antenna for the GPS. And then this yellow cord going from pin D3 on the ESP is going from here through a resistor to pin 13 on the Arduino Uno. It is important to note that the Uno is powered by the ESP8266, where the 8266 is plugged into a portable charger. So looking at the Uno, 90% of the pins on the Uno are used to control this 4-digit 7-segment display. I removed 2 of the pins for these first 2 digits because I did not need them, so that I could also get some space to put in this buzzer here, as well as get room for pin 13, which would allow the ESP8266 and the Uno to talk to each other. After we have all the wiring stuffed into our phone box, we could seal it up, close it up, and put it on the side for a thief to steal. If the thief comes up and steals the phone box, and they take it far enough away from the initial location, then they will begin to hear beeping. I've walked far enough away now and it's beginning to beep. There's my house. The thief will open it to see this bright red numbers counting down, simulating a bomb. In real life it doesn't flash like that, it's just the shutter speed of the camera. And then once it hits 0, it just continues to beep like that. And the thief cannot turn it off without destroying the package. After the thief steals the package, that or ditches the package because they're afraid it's going to explode, you can go into the Blink app, as seen here, click the top right button, and it will take you to the current box location. As you can see, the current box location is right here, and the initial position is here. So you can see where the thief is or where they dropped off the box. Some issues I ran into while doing the project. One was getting the geofence to work correctly so that I could get a radial geofence instead of just a square one. Another problem I had was adding the buzzer to the countdown example code, as it kept giving me a little trouble with timing. And the biggest problem by far was getting the ESP8266 and the Uno to communicate with each other. Most of my time spent on this project was troubleshooting this issue. This has been my anti-package theft prototype, and thank you for watching.